Find the volume of the solids below. Well, the first one, we can see the end here. It's a prism. So that's just going to be the area of the end times the length. And we're actually given the area of the end. So the volume here is going to be 20 times 8, which is 160. And that would be in millimeters cubed. Now we've got this cone. Now we really want the height, not the slant height. But looking at the 10 and 6, I think I can find the height using Pythagoras. And 10 would be the hypotenuse here. So we've got the square root of 10 squared take away 6 squared. And that gives me that the height is 8. And the radius is 6. So we've got everything we need for a cone. It's going to be 1/3 times the area of the base, which is pi r squared. So in this case, that's pi times 6 squared, times the height, which we just worked out was 8. And that's just a case of calculating. So we've got 1/3 times pi times 6 squared, which is 36, times 8, gives me 301.6. And that one would be in cubic centimeters. So, the cylinder shown below left is full of water. It is poured into the cylinder shown on the right. What is the depth of the water in the second cylinder? So we've got to work out how far up it would come. Now, since this is in meters, this is in centimeters, we want them to be in the same units. So let's just convert this to 0.3 and 1.2 in meters. And so we can say the volume of the cylinder on the left there, call it V1, is going to be pi times 0.3 squared. So that's the area of the circular end times the height. And we can calculate that. So pi times 0.3 squared times 1.2 gives me 0.339 and so on. I'm going to use the whole number. And volume 2, well, it's the same volume obviously as the water in here, but we'll deal with that in a moment. That is going to be pi times 2 squared times h. So we can say that the 0.339 and so on is equal to pi times 4 times h. And therefore, h is going to be 0.339 and so on divided by pi times 4. So in other words, I'm doing my last answer and I'm dividing it by pi times 4. I have to put that in a bracket, by the way, or you use the fraction template to do it. And that gives me that h is 0.027 meters.